When you are looking at a truss with some forces on it, there are some members in that truss that might not be doing anything at that particular moment. They carry no load at all. And I'll just mention that is at that particular moment in time. Like right now, there's a force from that truck right here in the middle of the truss. There's no force over here on the ends. Those are zero force members. When the truck drives to the end of the bridge and is putting a load on this force, on this bar down here, it will no longer be zero force. But at this moment in time, it's zero. How can we figure that out? I want to show you a handy-dandy shortcut for figuring this out. And to do that, let's look at an example. So here's a truss made out of triangles, and it has some forces up on top and some reactions. All right, let's make a free body diagram of the joint at F. So you'll get your imaginary paper towel tube and you'll focus in on joint F. And there's a free body diagram at that joint. Remember what you know about equilibrium. The sum of all forces in the x direction add up to 0. And the sum of all forces in the y direction add up to 0. What do we know about x? Well, we've got two forces. Looks like they're in tension. We don't know how big they are, but we do know they've got to be equal and opposite because they have to add up to 0. What about the forces in the y direction? What have we got? Oh, all we've got is force Fc, and all the forces in the y direction add up to 0. The only one we've got is Fc, so it must be that Fc is 0. Let's move on to another joint. How about this one, joint E? So it's in equilibrium too because it's not moving. Here are two forces in tension in the x direction. They're equal and opposite, so they add up to 0. Here's one force in the y direction. How big is it? Well, all the forces in the y direction add up to 0, and we've only got one, so that one must be 0 also. How about going down to joint H? Same situation. All the x's add up to 0, so they're equal and opposite. All the y's add up to 0, so it's 0. Let's look at a different truss now. How about one with a sloping bar on it? And let's get our tube and zoom in on joint B. And let's see what we can figure out about that. Now this is a little trickier because it's at a slope. And you could leave your x and y axes where we normally have them in our 0 and 90 direction. But you don't have to. You get to decide where you want to put your x and y axis. You can put it any place you want to. So why don't we put them parallel along the axis of this sloping bar? And when we do that, if we call this sloping thing x, okay, there are the x's, equal and opposite. They add up to 0. The only thing going in the y direction is this bar BL, and y adds up to 0, so that bar must be 0 also. And this takes us to our handy-dandy shortcut, our rule. If there are only 3 forces in a joint, and 2 of them are in a straight line, the third one is 0. They have to be in a straight line. So like those bars there at the top, those are in a straight line. The third one is 0. That's the rule. 3 forces in a joint, and 2 of them are in a straight line, then the third one is 0. If you've got 4 forces in a joint, it doesn't work anymore. And if you've got bars that are not in a straight line, it doesn't work anymore. It has to be this special combination. Only 3 forces, and 2 of them are in a line. Then the third one is 0. So here are the 3 zero force members in this truss. Remember this example we looked at the other day? Are there any zero force members in this truss? You might notice that, aha, yes, there is. It's that one right there. 3 forces in joint C, 2 of them are in a line, the third one is 0. Now, when you are doing this, once you find a zero force member, it might be that it makes its next door neighbor zero force also. And I'll show you an example with this truss, which looks complicated, but we'll just work through it one step at a time. So let's look at joint H there. 3 forces in that joint, 2 of them are in a straight line, so the third one must be 0. HJ is 0 right there. Okay, and I've kind of whited out HJ now because it went away. It's 0. HJ is 0. What does that do to bar GJ here? Well, if this other guy is 0 now, at joint J you have 3 forces in that joint. 2 of them are in a straight line. The third one must be 0. Yay! So that one is 0 also. Okay, so I whited that one out. Now let's go up to joint F here. There are 3 forces. 2 of them are in a line. What about the third one? Ha-ha! The third one must be 0. FO is 0. Okay. If FO is 0, and now I've whited it out, what does that do to this one, GO? All right. If this guy was 0, that leaves only 3 forces in joint O. 2 of them are in a line. The third one is 0. All right. GO is 0. What does that do now to GK? Let me see, which joint should we look at? Let's look at joint G. With all these other guys 0, now when we look at joint G, we see only 3 forces in that joint. 2 of them are in a line. The third one must be 0. So GK is 0. All right, now what? All of this stuff inside here has turned out to be 0. What does that do to this bar, EK? Let's look at joint K. It's got 3 forces. 2 of them are in a line. EK must be 0. So look at that. The entire inside on the right side of the truss is not doing any work at all right now, which kind of makes sense because all the forces are over here on the left side of the truss at this moment. All right, let's go look at this joint B over here, and let's think about BM. So at joint B, we've got 3 forces in that joint. 2 of them are in a line. The third one must be 0. All right, what does that do to CM? That leaves us with, at joint M, 3 forces in that joint. 2 of them are in a row. 2 of them are in a straight line. The third one must be 0. Okay, what does that do to another member? Does that affect anything? No. Why not? Because now at joint C there are 4 forces, and 4 forces is too many to have any 0 things. You can only have 3 forces in order to have this thing work. There are 4 forces up here, so no go. What about up here at joint D? You might be saying, aha, there are 3 bars in joint D, and 2 of them are in a line. Not so fast. No, that doesn't work because there are actually 4 forces at D. You've got those 3 bars, but you've also got that force P coming straight down. So joint D has 4 forces acting at it. So in this truss, what we discovered is that there are 8 zero force members, and I have marked them here. I've whited them out and I've put zeros on them so we can see them. Well, let's think again about this truss that you are beginning to draw from your assignment from last time, and maybe you have already drawn the free body diagram of the truss as a whole. You've got your reactions drawn, you've got your forces drawn. Now you want to think about, are there any zero force members in this truss? Yes, there are 5 zero force members in this truss. So find a place in this truss where you've got, what's the rule? You've got only 3 forces in a joint, and 2 of them are in a line. Can you find a joint like that? I'll bet you can. That third one will be 0. And then will it affect its next door neighbor? I bet it will. And so on and so forth. You'll be working your way across the truss and you will find out that 5 of those bars are zero force members and you don't have to think about them. So let me know if you get flummoxed by this, and we'll talk about it some more. Then we have a quiz coming up here, a zero force member quiz with a couple of trusses in it, and all you need to do in this quiz is just figure out which of these bars is a zero force member. So you're going to look and see, do you spot anything in here where there's a joint with only 3 forces and 2 of them are in a line? And if you do, does that affect anybody's neighbor? Does that make the next door neighbor 1, 0? Let's see, how many zero? I should have written the answer here. 1, 2, 3, 4, 5, 6. I think, if I'm remembering right, there are 6 zero force members in this truss. And then the second truss in this quiz looks like this. Find the joints with only 3 members in them, 2 of them in a line. The third one will be 0. I think this truss has only 2 zero force members. But let me know if you have trouble with this.